Okay, here we have a trig substitution problem. We know it's a trig substitution because we see a 1 plus x squared sitting inside a radical. Now, it's not the usual radical that you usually expect when you see a square root, but it is, that power of 3/2 really tells us there's actually a square root sitting on this 1 plus x squared. Now, the three forms you need to know when you're doing a trig sub is a plus x, or a squared plus x squared, a squared minus x squared, and x squared minus a squared. And this form is a squared plus x squared. Here, a squared equals 1, which tells us that a equals 1. That's a silly one, but if a squared was equal to 4, then a would equal 2. If a squared equal 9, a would equal 3, and so on. So now, because it's of this form, a squared plus x squared, we're going to make the following substitution. X equals a tangent theta. A is 1, so you can put it here, 1 times tangent theta. The next step, once you choose your suitable value for x, we're going to say dx equals, the derivative of tangent theta would be secant squared theta d theta. The next step, once we have x and dx, is take these things and throw them into the integral. I'm going to recopy the integral. I'm not even going to worry about the bounds. The bounds aren't too important here, but I'm going to replace every instance of x by tangent theta and dx by secant squared theta. So I have 4 over 1 plus tangent squared theta. And d theta, or rather dx, gets replaced by secant squared theta d theta. Okay, this looks kind of like a mess. And I always say, all right, the next step is to integrate, but you're not going to integrate right like this, just that mess here. So we need to simplify it a little bit. We're going to go over to invoke an identity. This is an identity you need to know. 1 plus tangent squared theta equals secant squared theta. So I'm going to replace this 1 plus tangent squared theta by that secant squared theta when I rewrite this integral up here. We have 4 secant squared theta over secant squared theta to the 3/2. All right, we're going to continue simplifying. Secant squared to the 3/2 means you're going to square root this guy, and then you're going to cube it. We can square root secant squared, and that will give us secant. But then we're going to cube it, and that's going to give us secant cubed. So secant squared to the 3/2 is better known as secant cubed. So 4 secant squared theta d theta over secant to the 3rd theta. Okay. Further simplifying, I know it seems annoying to have to keep simplifying this much. Secant squared divided by secant cubed. Remember that secant squared, or rather just secant, is 1 over cosine. So this is 1 over cosine squared divided by 1 over cosine cubed. Those cosines are going to flip to the top, thereby giving us 4. You could say cosine cubed over cosine squared if you wanted to. Let's just write that. Cosine cubed over cosine squared. And now we have the integral of 4 cosine theta d theta. All right, we're almost out of the woods. Now it's actually time to integrate. The integral of 4 cosine theta is equal to 4 sine theta. That's the actual integration now. Finally, don't forget plus c. And we're going to use a right triangle to do the back substitution. So what right triangle do I use? We go way back to the original substitution and say x equals. We'll say x equals 1 tangent theta. Let's say x divided by 1 equals tangent theta. Let's divide both sides by 1. Again, I know it seems kind of silly to divide by 1 because that doesn't change anything, but it really is going to help us set up this right triangle. So I'm going to draw a right triangle with an angle theta, whose tangent of that theta will give me x over 1. So remember, tangent is opposite over adjacent, so we have x and 1. Using the Pythagorean theorem with these two as the legs, we square this side 1, we square this side x, we get x squared plus 1, take the square root, and you get the square root of x squared plus 1. So that is this hypotenuse side of this triangle. Well, our answer is 4 sine theta. So using this right triangle, you can tell me what the solution is based on the angle theta and based on the sides of this right triangle. So our answer is 4 sine theta. We say sine theta is opposite over hypotenuse, so we're going to replace sine theta by the opposite, which is x, over the hypotenuse, which is the square root of x squared plus 1. Don't forget plus c. Actually, there is no plus c because I think we had bounds in this guy. So, whoops, 0 to 1 are our bounds. No plus c is needed. We're just going to evaluate from 0 to 1. So we're going to plug in 1, plug in 0, and find the difference. When I plug in 1, I get 1 over 1 squared plus 1 is 2, so we have 4 over square root of 2. Minus what I get when I plug in 0. Thankfully, when I plug in 0, I get 0. So my answer is 4 divided by square root of 2. You could leave it as that, or you could say, rationalizing the denominator, you could say this is 2 square roots of 2, and that is your final answer. That's how you do that trig sub problem.